Hey guys, welcome back to another video. Today we're doing another UKMT question. So the question is, the diagram shows two concentric circles with radii of 1 and 2 units, together with a shaded octagon, all of whose sides are equal. What is the length of the perimeter of the octagon? So to make it easier, we'll draw the diagram again. So we have our bigger circle on the outside, then we have our smaller circle on the inside, both which have the same centre, and that centre we can just call T. And then our four triangular shapes, whose sides are all equal and they're all shaded. So this whole is shaded here. So we have that, then we have our T in the middle. So we have our T in the middle, so we can draw a line, and then we can label some points that we can use. So we can use P here, and then our Q here, because to find the length of the perimeter of our octagon, we would have to find one side of it. So this side would be what we'd need to find, and then we can just call that PQ. So then we can draw a line from the centre on upwards to P, basically, which ends here. And then obviously in this, and then we could connect the centre to the Q. So we have this shape here, but this triangle doesn't have a base of any sort, and we'd have to find a base to find the length of PQ. So we can add a base that goes perpendicularly from Q here. So now we can draw this green triangle again to make it clearer to us. So we have our point P here, and then we go down to point T, and then we have our Q here, and then we can label this O, and then we have our thing here. So we can use some knowledge that we know, so we can prove that OTQ is 45 degrees. We know that because if we make equal sectors of this sphere, this circle, and because we know there are 8 parts in an octagon, you would split it evenly 8 times, and those 8 out of 360 degrees, so 360 divided by 8, which is 45. Therefore, we know that each equal sector would be 45 degrees. So yeah, 45 degrees here, and then we can say that this is 90 degrees because we took it perpendicularly from Q to O. So that's 90 degrees, and then we know the whole length of PT is 2, because it's from the centre to the bigger circumference. And then we know that the length of TQ is 1, because it's from the centre to the edge of the blue circle, so which is 1. So we know that, so then we can use some Pythagoras theorem to find out... Oh, okay, so we find out the length of PQ. So to do that, we would have to find more sides first. So we can prove that OQ equals OT, because if this is 90 degrees here, like this like all angles on a straight line are 90 degrees, then this is 90 degrees, which means that this angle must be 45 degrees. So if there are 2 angles which are 45 degrees, then OT and OQ are the same length. So we can just leave it as that for now. So we know these 2 are the same length. So to find the length of PO, it would just be 2 minus TO. To find the lengths of TO and OQ, you would use Pythagoras theorem on the smaller triangle here. So we have our 1 here, and then we have our OT and Q. So then using Pythagoras theorem, it would be just OT squared plus OT squared, because OQ equals OT, so keeping one term would be fine, equals 1. So together that's just OT...
2 OT squared.
So yeah, so that would just be 2 OT squared. So OT squared would be 1 over 2. And then OT would be the square root of 1 over 2. Yeah. So that's no. So TOOT is square root of 1 over 2. So then our length of PO then becomes 2 minus 1 over root 2. Or yeah, and then we can then use Pythagoras theorem, and then we can use Pythagoras theorem again to find out the lengths of our bigger triangle. So we can draw the triangle again, knowing our new lengths now. So we have our P, we have our Q, and we have our O. So we know the length of PO is 2 minus 1 over root 2. And then we don't know PQ yet, but we know that OQ equals OT, so this is just 1 over root 2. So now we can use Pythagoras theorem again to do 2 minus 1 over root 2 squared plus 1 over root 2 squared, which equals PQ squared. So doing each separately, 2 squared is 4, and then minus 4, and then minus 1 and root 2 squared, so minus 1 squared. So minus 1 squared is 1.
प्लस करेंगे जब स्क्वायर कर रहे होते हैं तो फर्स्ट टर्म इज 2 स्क्वायर्ड प्लस इसका स्क्वायर.
Oh, right. Plus, so then 4 plus 1 squared, which is 1, over root 2 squared, which is just 2. So half, basically. And then that...
नहीं, and minus फिर इसका product. 2 times.
Minus the product of 2 and minus 1 over root 2, which is 2 over root 2.
नहीं, 2 times इनका product.
4 over root 2.
4 over.
Plus, and then 1 over root 2 squared is just 1 squared, which is 1, and then 1 over 2. Which equals PQ squared. So then we can add the like terms which we have. So we have our 4 plus half minus 4 over root 2 plus half. So our halves cancel out.
नहीं, half तो half add हो जाएगा ना.
Oh, sorry, they don't cancel. The halves add together to get 1. So you have minus 4 root 2 plus 1. And then 5. Then you do 5 minus 4 root 2, which equals PQ squared. And then when we can simplify 4 over root 2, minus 4 over root 2 further, to say, to multiply both numerator and denominator by root 2. So you have 4 minus 4 root 2 over 2. And then simplifying that further, you would just get 5 minus 2 root 2 equals PQ squared. And then to get PQ, you just square root the whole thing to get square root of 5 minus 2 root 2, which equals PQ. And then because there are 8 sides in an octagon, you would multiply this length by 8 to get 8 times of root 5 minus root 2. So that's the answer. Thank you guys for watching our video. Please make sure to like, comment, subscribe, and see you next time. Bye.